Hello everyone, I hope you're all doing very well. In this video we're going to go over how to give your aircraft control surfaces and how to make them properly function. And without further ado, let's get right into it. So I have my aircraft from last time opened up, and right now, as you can see, I don't have any control surfaces whatsoever. This is a bad thing. You need control surfaces on your aircraft for it to properly work, obviously. And so, I'll show you how to do that today. Now the first thing you will want to do is you will want to go into the Wings tab, and you will want to assign control surfaces to various elements of your wing. Now this is best done, I think, personally in wireframe view. Doesn't really matter all that much, but it makes it kind of easier to visualize where things are going. And you will notice that there are all these checkboxes here, and each of these checkboxes is going to allow you to set what control surface type each individual element of your wing has. Now this is part of the reason why I like to max out the number of elements by setting this to 10 for at least my wings, just because it gives me more control over what is going where. Now, most aircraft have an aileron on the outboard end of their wings, and so I'm going to select aileron 1 for these last two elements. Actually, I'm going to make that 3 just so I have a bit more roll authority. Now, there are a lot of different types of control surfaces to choose from here. Normally on your wings, you want to only use ailerons, roll spoilers, flaps, maybe slats. And so now I'm just going to go through, I'm going to populate each element with a control surface depending on what I want it to do and where it is. So for the inboard sections of my wing, I'm probably going to want some flaps. And now, looking at these wireframe view again, you can see that this element is partially inside the fuselage. So I personally don't like to modify these and give them control surfaces if they're inside of my aircraft. That's just me. I think it looks a bit weird, so I'm not going to give any control surfaces to this element here. Instead, I'm going to start my flaps right here. And let's say I want them to go out to about here, so I'm going to click all those boxes to give myself some flaps. Let's say I want a bit more lift on approach and on takeoff, so I'm going to give myself some leading edge slats as well. And that's slat 1 or slat 2. And the reason why there are multiple different checkboxes for each type of control surface is sometimes you might want to assign different deflection values for different parts of the controls on your wing. Sometimes you may want to use some of your ailerons just as plain old ailerons. You might want to use some other ones also as flaps as well, depending on what kind of aircraft you're making. This is a pretty normal plan form, so on my wing, I think this is just about what I want. Actually, I'm going to also add some speed brakes just so I can slow my aircraft down when I land. Now, roll spoilers, they serve the same function as ailerons, but you model them in the same way you model speed brakes. I'm just gonna throw in a couple roll spoilers just to show you what that looks like. So that's basically all the kinds of controls you're going to want on a wing. And alright, so we've now assigned control surfaces to our wing. Now we need to go do the same thing for all of our other flying surfaces that we want to put controls on. So we're going to go back to wings. We're going to go to the horizontal stabilizer first this time. And now, for your horizontal stabilizer, you really have just two options really. And those options are to give it an elevator or to make the entire thing move with the deflection of your elevator. Just for the purposes of this video, I'm going to show you how to do both. It's pretty simple. So again, I'm just going to check and see this one element is partially in the fuselage. So I'm just going to leave that unchecked. And that's all you really need to do for your horizontal stabilizer. Now we're going to do our vertical stabilizer again, so same deal. I'm going to look at this. This element is partially in the fuselage. I'm just going to ignore this column entirely. And for the vertical stabilizer, your options are really only, if you have one, you probably just want to put a rudder on it. If you've got more than one, you're going to want to put a rudder on each of them. If your vertical stabilizers are canted at an angle, I'd say less than 45 degrees from the lateral axis, then you might want to consider making them elevators. So since this is just a single vertical stabilizer, I'm just going to make these 5 elements rudders. And that's all we need to do here. Right, so now this is the fun part. Now we get to go into the control geometry tab and assign a shape and deflection value to each of these controls that we've just made. So standard, and then control geometry is where that is. Now we're just going to go through the list, and if we've got one of these control surfaces, we're just going to give it a shape and deflection value. So each of these has a chord ratio. There's 2 boxes. This one's for the root of that control surface group. This one's for the tip. So this is the more inboard side, this is the more outboard side. And then you have your deflection values here in degrees. So for the aileron, I'm going to put in maybe 0.3. And if you just try to max it out, you see that you can only go up to half of your chord as any given control surface. So I'm just going to say 0.3. And if you look again, you'll see that nothing looks like it's changed. This is because I have not assigned a deflection value yet. Once I do that, you'll see it start to move. So a good rule of thumb that I have is just 20 degrees and leave it, unless you need more later, which you'll probably determine by flight testing. So I'm just going to say it can deflect 20 degrees up and down. And now you can see these last 3 elements of my wing are moving. And let's say, I'm just going to show you what it would look like if I wanted to make it bigger. So if I make the root have more of it be aileron, you can see that changes. If I do the same for the tip, now half of it is aileron. I don't want that much control authority, so I'm just going to leave it at 0.3. And the thing you have to be careful about here is if you don't make your control surfaces big enough, you won't be able to have enough control authority. If you make them too big, you'll have way too much, and you wouldn't want that either way. So my general rule of thumb is just to kind of start with 0.3, having a third of your chord be the control surface is usually pretty reasonable, and then adjust as needed. Again, for control deflections, for starters, just stick with 20 degrees on everything. If you need to, if you're finding that you have too much authority in a certain axis, you might just want to tone it down just a touch. So we're just going to go down the list and see if we've got any of these other control surfaces. So aileron 2, we don't have one of those. If we did, we would create it the exact same way we just did for the aileron 1. We just select the aileron 2 boxes along any point on our wing that we wanted to, and then we'd assign it size and deflection the exact same way. Now elevators, we do have some of those, and we're just going to say 0.3, 0.3, that seems reasonable for this aircraft, and 20 degrees. So this says aircraft nose up and down. That really doesn't mean anything relating to the aircraft's nose. This is just referring to the amount of deflection in degrees of this control surface. So now if you were to instead of giving yourself an elevator, you wanted an all-moving tailplane, you would keep your deflection values the same in control geometry, and if you were just starting out with making this, you wouldn't need a size of control surface because the entire chord of the wing is a control surface. So just to show you what that looks like, I'm going to deselect elevator, and I'm going to say incidence with elevator 1. Now this will vary the entire incidence of the elements you have selected with the deflection values you assigned for elevator 1 or elevator 2 if that's what you want to do. And I'll just keep it like that because this aircraft is probably going to end up as a fighter, and I want to have a good amount of elevator authority for a fighter. Now we're going to go back to control geometry, we're going to move down this list, and hey, we've got a rudder, so let's give that a size and deflection. So again, I'm just going to say 0.3 and 20 degrees in either direction. And now the best way to find out if you're not quite sure how this is going to perform in X-Plane, the best way to do this is just to test and see if you pull the stick all the way back, does the aircraft not really move that much, or does it move so much that you start buffeting around a certain angle of attack, in which case you just tone it down a bit. So that's how you create those basic control surfaces. Now, keep going down the list. Roll spoilers, we do have some of those, and now these, we assign them a chord ratio the same way we do for the other things, except you can see it's the chord ratio of what's left after you've assigned some other control surface. And so that's what that looks like. You can kind of see it here, maybe not too easy to see. So you don't assign a downward deflection value for these because if they deflected down, they'd go into the wings of your aircraft. So we're just going to say maybe 20 degrees on the roll spoilers. And roll input to engage is the value that determines whether or not there's a zone in your controlled movement where these don't deploy. So if you just leave it at 0, they will deploy no matter how little or how much you move your controls in X-Plane. If we were to say 0.25, you could move your joystick or your mouse a quarter of the way over in your roll axis, and these would not deploy. If you exceeded that, however, they would deploy 20 degrees. Or, sorry, they would scale accordingly up to 20 degrees maximum. And same thing, so I don't really want these to deploy unless I really want to slam the plane around, so I'm just going to say 0.75. Excuse me. And now the process to create speed brakes is the same as it is for roll spoilers, so I'm going to just say 0.1 and 0.1 because this is at the root of the wing where the chord is much larger. And you have two deflection values for speed brakes here. You have an in-flight deflection and a ground deflection. Now, depending on how you set up your controls in a more advanced way, X-Plane might let you reach the ground deflection while you're in flight, but usually it won't. So the flight deflection is what you'll get when you tap the speed brake extend key twice in flight, and the ground deflection is a bit more for when you're on the ground, or you can make it a bit more for when you're on the ground. So I'm going to say it can go up to 60 degrees on the ground, so when I'm landing I can slow down nice and quick if my brakes fail. So next thing you want to go over is flaps. And we do have flaps on this aircraft, so we will want to assign a shape to our flaps. If you were using your ailerons as flaps, which I'll talk about in a later video, you wouldn't need to assign a size for your flaps, and you could just skip straight ahead to assigning extension values for each detent you have. So I'm actually going to start with my slats. I do have slats, and I'm going to make them be slats. And when they do that, X-Plane says that these will increase my stall angle of this airfoil by 8 degrees from leading edge device deployment. That's fine, I don't need to change that. I like that where that is. Excuse me. So now for my flaps, I'm just going to say I want them to be 20% of my chord. Actually, no, that's not very much. I'll say 30% of the chord. And so I'm going to explain that in just a moment, but now that you've given these a size, we can give these a deflection value. So now, these are your flap settings. So each time you press the extend flaps key, you will move one over throughout this range, and then when you retract, it'll go from the largest value that you have all the way back up to your least value each time you press your flap key once. So I'm going to say, let's say I want 4 flap detents. That's what those are called, flap detents. And when I press that key once, if I want my flaps to go down by 5 degrees, I will say 5 right here. Now you'll notice that all of these have a minimum value of 5 because they can't be less than the value they're already extended to. So next, let's say I want to go to flaps 15. And so now you'll see they're deflecting just a bit more. So this is probably a decent takeoff setting. Now, let's say I wanted that value to be 25, and then for my very last one, I'd want either 35 or 40, usually not much more than that, or they'll create too much drag to really be super useful. And so right now you can see they're just pivoting down like they're a normal control surface. This is fine in some cases. Other cases you want a bit more, you want to get rid of some of that drag. You can actually change the type of flap that you have. So right now these are plane flaps. Xplane's tooltips do a pretty good job of explaining what these are. So a plane flap, it says here, simplest type of flap, it just pivots down. A slotted flap pivots down and out a little bit, and it creates this slot, hence the name, and this produces a bit more lift. And then there's slotted fowlers, so these move back and down, so same performance benefits as the slotted flaps plus a little bit. Then there are double slotted fowlers and triple slotted fowlers. Some aircraft, like airliners, usually have multiple slotted fowlers. And Xplane doesn't give you a visualization of this, but basically there are just more gaps in this part of the flap, which produces much more lift than a normal flap would. So I'm just going to go with a simple slotted flap for this, because this isn't a super large aircraft, and I'm not going to have to worry about weight all that much when I take off. And so that's how you create your control surfaces. Most of these other tabs you don't really need. I'll talk about this one just a little bit in a later video, just because it's pretty useful for fighters. This one is useful if you want to make your controls feel a bit more realistic in Xplane, although it's not required at all. And this one is useful if you don't want to put speed brakes or spoilers on your wing for whatever reason. You should still definitely have one. I just recommend it kind of as a rule. It's just good common sense to have another means of slowing down your aircraft if your brakes fail or something. So to make a speed brake, you can you select in this menu body mounted, and when I switch to wireframe view, you'll see there's this little thing that showed up here, and it matches the shape of this. This is a speed brake. It's really just a little kind of wireframe sheet that Xplane models that produces some parasitic drag when it's deployed, which is very good for slowing your aircraft down. Now right now it's quite small, so I'm going to make the maximum size of this much larger. So first I just want to extend that out a bit. So this is how you shape your speed brakes. As you can see, I move this point around here. You can see that moves around here. So these are the corners of your speed brakes. And I am going to this is different. Sorry, I normally work in a different version of Xplane. Oh, right, okay, so to make your speed brakes max size bigger, Just want to pop into landing gear very quickly, go to gear data, and then increase this to maybe 10 or 8 feet. So that'll be the maximum distance you can move each individual point back. So now you can see I have a lot more room to work with. So this is a pretty large aircraft, so I'm on a pretty large speed brake. I'm just going to try to get a rectangle. I'm just going to wait for those anti-aliasing artifacts to go away so it looks like a straight line. And there, I've got a nice speed brake now. And speed brakes are positioned the same way most everything else is positioned in X-Plane, along the 3 axes or arms. In this case they're not labeled, but it goes, the order is longitudinal, lateral, and vertical. So I'm going to move mine 20 feet back now, let's say 30 feet back on the longitudinal axis. And right now, if it were to deflect all the way up, it would barely come out of my fuselage, so I'm going to move it up just a bit so that it doesn't poke out while it's retracted. So now that you've made it and positioned it, the next thing you're going to want to do is allow it to deflect. So this value right here is the extended deflection of your speed brake. I'm going to say 60, 60 is a good value usually. And then this is the retracted deflection. I'm just going to leave that at 0. I don't really need to change it to anything else. And there you go, now you have a speed brake. So if you've got one of these and it's a nice big one, you don't really need speed brakes on your wings. This is a fighter. I like having a dedicated speed brake on fighters just because that's kind of how I've done things in the past. So I'm just going to get rid of this, and there you go. Now that's a basic control design for a pretty standardly configured aircraft. I hope you were able to find this helpful. If not, as always, please come to office hours and Jason and I can help you out. And I think that'll be it for this video. Have a good night, and I'll see you in the next one.